Hello, welcome to my Tech Fun. In this video I will test the Flashforge Adventurer 5M Pro 3D printer. The Pro version is fully enclosed and this is a coreXY fast 3D printer with a price of approximately $550. Of course the price depends on your country, but this is quite good price for these specifications. Now the build volume is 220 millimeters in X, Y and Z direction. It used some kind of, let's call it clipper-like firmware, because it is closed source, so it cannot be clipper, but let's call it fast firmware. The temperatures on the nozzle, the maximum is 280 degrees Celsius, which is good enough for most of the technical filaments. I have some filaments, exotic technical filaments, which requires to be printed closer to 300 degrees Celsius, so I'm missing those 20 degrees, but for most cases this will be quite enough. And the bed temperature maximum is 110 degrees Celsius. Now, a very important feature of this printer is the fast changing nozzle. And thanks to this feature, probably I will donate it to my department and I can relay on my students to if I want to replace the nozzle. So I can give them to replace it because this is just one click, no tools are needed. This is the first time I saw this kind of solution and it's really great. It used the direct drive extruder, inbuilt accelerometer for the input shaping. Now it also has the built-in circulation filtration of the air, which can be internal and external. You know, external, then it sucks the air from the room. Very useful if you don't need higher temperatures, printing PLA or something like that. But if we print, let's say, ABS, and then we should choose the internal circulation. In that case, we are not losing the heat inside the enclosure. It has some auto shutdown function, which may be useful. It uses the nozzle to probe the bed for the auto leveling, but the load sensor is not in the extruder like on Russo Mark IV, but the load sensors are in bed. I already analyzed the pictures of the printer and I really like that we will have a nice view to the nozzle. But I don't like the spool holder is on the back side. I don't know what is this new trend, but nowadays every new coreXY printer places the spool holder on the back side. No, we need on the side. Forget about backside. That's maybe in laboratory you have the space, you know, from the backside of the printer, but users, no. Many users like to use the Orca slicer, but it looks like the Wi-Fi is supported only if we use it with the flash print. So on the software side, I think they require some development, but of course I will check this. I already analyzed the videos about this printer, and it looks like that many users have a problem with bed adhesion if they send the printing over the Wi-Fi. If they send over the USB, then they can tick that leveling button, and in that case the bed adhesion is better. So definitely I can see from software side that it requires some improvements. Maybe it is solved by now, we will see, but let's see what's in the box. The packaging is good, the printer is really protected during the shipping, and this is fully assembled 3D printer, and the only assembling it is needed is mounting the spool holder. All other parts, sample filament and the tools are inside the printer. This is content of the package and a pleasant surprise. SanDisk USB drive, 250 gram PLA filament on the spool. Then we have some tools, glue stick, and this is a spool holder. And this is the spare nozzle, 0.6 millimeters. And from the color, I think this is some kind of hardened nozzle. I'm not really sure what nozzle is installed. I hope I will get the answer from the Flashforge. Let's take a closer look. I will start from the inside. So here we have textured PI sheet, which is two-sided, and it is very pleasant to place it back because we have some guide on the back side, and I can always place it back to the same position, and we have this nice holder. I can see some yellow arrows, so I have to remove these screws. I have two here on the front and two on the back side. These are for the transportation. They hold the Z-axis in the same position. I can see three lead screws, and I can see two on the front and two on the back side linear rolled. So this is the guide for the Z-axis. This is the ventilation fan, and I can see some filters inside. And this is the aux fan, you know, for additional part cooling, especially if you print PLA or something like that. From the inside I can see the typical structure for the coreXY. They use the metallic rods on X and Y axis. These are 6 mm timing belts approximately, and they use the drag chain. So here this is the cable for the extruder, the power and similar, and this is for the filament which has to be inserted. This is direct drive extruder, so it will actually pull the filament from the backside. I already mentioned that we will have nice view to the nozzle because the part cooling is from two sides and the front is free. Unfortunately, that view will be from quite low angle because this front frame covers the view. So we have to watch it or from this quite low angle or maybe from this angle, but from here we cannot see the nozzle. This is the touchscreen slot for USB drive, and this is some kind of button for the power on, but I think this is some kind of software button. Because on the back side we have the hardware button too. Here I can see the connection for the LAN cable, and this is for the power cable. And these are holes for the ventilation. The spool holder must be mounted here. And through these openings we can see two bolts from each side. This is for placing the tension on the timing belt if necessary. But I already checked, so the tension is quite good out of the box. I also like that the top cover is on the hinge, so we can just open it and it will stay here. It's not like removing completely, then we have to find some space on the desk to place it there. You know, for the plating with the PLA, it is very important to be open because the PLA needs more cooling. Okay, so I mounted the spool holder, it's on the back side, and it looks like the maximal thickness of the spool is approximately 79 millimeters, which is fine. And this is the Teflon tube where the filament goes in, and it is on the side, so this is good sign because probably I will not use this kind of spool holder, but maybe I will place here some filament dryer and use it directly from here. This is the bottom side of the printer. This is the shaft from the stepper motor for the Z-axis, and these are those lead screws connected here, and they're also connected with this timing belt, so it keeps it synchronized. And this is the tensioner for this timing belt. All four securing screws are removed. I connected the power cable and let's turn it on. Choosing the language, and it will start with fully automatic calibration. We have some warning that we have to remove the packaging material and those securing screws. And now we have to do some calibration, which will take approximately 9 minutes. It starts with the input shaping now. Now it asks me to load the filament according to these instructions. It is nice to have these pictures on the screen. The filament is loaded. I can see it was tested with some red material. 10 minutes for unboxing and assembling, and now 10 minutes for the calibrating, and it's ready for printing. Some kind of calibration cube. It starts with the printing. The nozzle is on 220 degrees Celsius and the bed is only at 50 degrees Celsius. I hope it will be enough, but so far the first layer looks okay. And from the second layer it started with the fans and it speeded up. Definitely very fast printer. This will be very fast printing, approximately 6 minutes. Now, according to user manual, I should apply some glue on the surface, which I didn't do. I hope this first printing will be fine, because the temperature on the bed is only 50 degrees Celsius. As I predicted, unfortunately. Okay, cancel the print. I canceled the printing because the adhesion was quite weak. Now if I analyze the first layer of this printing, I can see that the Z offset is a little bit too high. Definitely if I would set this manually, I would go lower a little bit. Maybe then I will get a better layer adhesion, but definitely 50 degrees Celsius is maybe okay if I use the glue stick with this, but with PLA I don't want to use the glue stick, so I will go up to 65 degrees Celsius on the bed surface. First, I want to be sure that there is no contamination by default. I mean, sometimes they put some kind of protection layer in the factory. So I'm cleaning first with the hot water and the soap. And when it dries, some isopropyl alcohol. These are the G-codes I can find on this printer, and there is a Benchy. It's a little bit risky to test the bed adhesion with the Benchy because it has very small contact surface, but let's give it a try. And if the default bed temperature is less than 65 degrees Celsius, then I will change it because I don't want to use the glue stick with the PLA. It starts with the leveling, but for example, it will be useful if we do the leveling only on the print surface, which is much smaller in this case. Now it's preheating, but the bed temperature default is 35 degrees Celsius. No way. I'm changing that to 65. It would be better if it would wait in the front corner, because in that case I could clean the nozzle, but now it is very risky to go with the tweezers, go back there, because this is very fast printer. Now it started with the printing, and it is raising the temperature to 65 degrees Celsius, but I'm afraid maybe it will be too late, but we will see. The first layer looks okay. After approximately 5 minutes, the printing is okay, and actually this will be 14-minute Benchy. I really like this clear view to the nozzle. And it's really finished in 14.5 minutes. Immediately let's check the bed adhesion. It is great now. And when it cools down, perfect. And now let's analyze this 14-minute Benchy. So this is the first layer, which looks great. The side surfaces. Absolutely no stringing here. Great overhang, so even the part cooling is enough for this fast printing. Very happy with this quality and with the bed adhesion. I can see two more G-codes I want to print, and that's this gear bearing, and the other will be this scraper. Looks like on all G-codes the bed temperature is set to 35 degrees Celsius, so pay attention to this if you don't want to use the glue stick. I can even set the Z offset if necessary. But changing the Z offset was too late now, because it already started with the second layer. Printed in 38 minutes. Bed adhesion check, and it's okay. So 65 degrees Celsius is okay, and we don't need a glue stick. And when the bed cools down, perfect. And I need a scraper to remove this purge line, and it would be much easier to remove it if it is on the front side, not on the back side. Printed in approximately half hours, and the bed already cooled down. And now let's check if it works. Great. But it will be more comfortable if the purge line would be here. Well, the nozzle and the bed temperature cooled down, but it would be good to have some kind of standby mode which is quiet. I can constantly hear some fans from the back side, but let's see this button if it will work. Okay, at least it works, and I didn't test the auto power off, but I think that will be very useful. But it would be good to have some kind of standby mode when it will be completely quiet. I noticed that even if it is turned off on the switch on the front side, I can still hear some fans inside. And now the harder switch. And only now it is quiet. Now let's see what's on USB drive, and let's prepare the slicer. In Download Center we can see first information about the Orca slicer, how to add this profile to the printer. And then only with the next step we can find the FlashPrint software. This is their slicing software, and don't forget we have to use this software if we want to use the Wi-Fi connection. And this D12 dice will be the first printing, and I am changing the bed temperature to 65 degrees Celsius. Slicing and downloading and copy to the USB drive. Nice to see the thumbnail image, and pay attention, by default now the leveling is enabled, but later after further update it will be disabled by default. $30mm in height, printed in 13 minutes. Great bed adhesion. The bed cooled down. Oh, it's completely removed. And actually much more interesting than the calibration cube. This is along the z-axis, not bad, but definitely I think I should go lower with the z-offset. So this is that first layer, and actually absolutely no ghosting on any side, and this is the top layer, the number 12. And in settings now I noticed that it has a camera, but it was not enabled. Let's enable it, and next time I want to create some video. Now I want to replace the filament and print something from this dual color silk filament from everyone, and I will print that owl, but now I realized how strange is this unload function. So if I follow the instructions on the screen, I have to take out this Teflon tube and then cut the filament. I inserted the new filament and it will be switched to new color. This is the first time I can see this kind of filament change method. So usually it extrudes a little bit and then goes back, and then you can pull it out and replace the filament. So this is the first time I can see this kind of filament change. So what is your opinion about this? Is it good or bad? I'm not really sure. I'll print. For Flashforge PLS settings, the default was 25 cubic millimeters per second, but here I limited to 20 because I'm not really familiar how can this filament handle these higher speeds. Really nice first layer. This is now the second one. After 1 hour, the printing is at 50%. Printed in 1 hour and 58 minutes. The printing looks really nice, only this seams line is a little bit ugly on the back side, but otherwise great printing again. And this is the time-lapse video, and I think with this I will copy it to this USB drive and then I can transfer it to my computer. And we can also see the preview on the screen. On printer screen it looks okay, but the quality is not something what I will use in YouTube videos, but it is good to check the printing over the network. And now I want to connect to the network and to see the possibilities. It looks like it is connected and now it offers some update. Let's check it. This was fast, updated in maybe 10 seconds. Please restart the printer. Okay, how? With the button? Oh, it is updating now after the restart, okay. And approximately 2 or 3 minutes the installation is finished. Interesting problem I noticed: when I connected to 5 GHz network, it was recognized and it finished the update, but I couldn't connect with the flash print. Now I switched to 2.4 GHz and now it's also connected with the flash print and it works okay. So with 5 GHz it doesn't work completely good. And now I'll start one printing over the network. It will be a D6 dice, quick printing, but I'm curious it will do the leveling or not before the printing. This is a D6 dice, something like a calibration cube, bed temperature of 65 degrees Celsius, and now I'm uploading over the network. The printer is recognized, and immediately it will start with the printing. The file is transferred successfully, and let's see if we will have the leveling or not. Well, it started with the printing without that leveling, so let's see if that adhesion will be okay. And it's true, I have to stop the printing. Well, the Z offset on this first layer is really high, so I can confirm that problem which other had. If I start the printing over the network, we don't have that leveling option on the screen, and yes, the adhesion is not good. And now I'll repeat the same printing because the file is already stored in the printer. Here it is. And this is that leveling. Look, it is not enabled by default. And now let's print. And now correctly it starts with the leveling first and then it will start with the printing, so probably this will be okay. And this side the printing looks much healthier. From the screen I'm missing current Z coordinate. It will be good because then precisely I will know when we'll be finished. But this will be very fast printing anyway. It's finished in 7 minutes. Let's check the bed adhesion. It is good. Okay. This is the top layer, the first layer, and side surfaces. And now I want to print something from this ABS, but also I want to replace the nozzle. This is 0.6 mm hardened steel nozzle, because the installed one 0.4 steel nozzle. Now, because of this very strange filament change method, I cannot just unload this filament. Let me show you this method. So I have to remove the Teflon tube, cut the filament, and now I have to take out the previous nozzle. And then I can cut here the old filament. So this means with this method I always have some filament inside this nozzle and the heat break. And now I will insert this one. This is the hardened one, 0.6 millimeters. This part was easy. The new filament is prepared. ABS. The nozzle is preheated and it's loading on the other side. The filament is changed. Now I will close the doors. And it's much quieter now, at least. And I will check this internal circulation filtration. Enabling the leveling, very important. It's not completely that capacitive touchscreen. It needs to be pressed a little bit. Since the latest firmware update, before the start of the printing, it always goes completely down with this print surface. I'm not really sure why. It's a little bit hard to see, but the first layer is okay. Now it started with the second one and it's speeded up. With ABS printing, at the beginning it is heated by the 100 degrees Celsius from the heated bed. Later, after maybe 5 or 6 millimeters, it starts to be critical. To prevent the warping, we need some enclosure and high temperatures in the environment, and after 10 minutes or maybe 15 minutes I will measure what is the temperature inside the enclosure. The sealing is good from all sides. It is not easy to find some gap for the temperature sensor. Okay, so this is the position of the sensor, and let's see the temperature now. After only 10 minutes, the temperature inside is approximately 40 to 43 degrees Celsius, which is quite good. After approximately 2 hours of printing, I cannot really feel that smell of the ABS, so these air filters works great, well, at least until they are new. The object looks perfectly straight, but I will analyze it later when I take it out. And the maximum temperature inside the enclosure was 55 degrees Celsius, at least on this position where the temperature sensor is. Oh, and now when I open the door I can feel the smell of the ABS, so that filtration works great. Bed adhesion is great until it's hot. I will wait until the bed cools down. From this purge line I can feel that the adhesion is very good, maybe even too good. And probably because on 100 degrees Celsius it should require some different leveling, actually the Z offset. But I don't worry about the object, so with the flexing of the bed it will be removable. And from this first layer I can see now the nozzle was much closer to the bed compared to 60 degrees Celsius on the PLA. But this object is great, really straight, absolutely no warping, so this enclosure is great. I'm also printing a few more parts from this ABS. And this is a really functional part with 100% infill from ABS, and you will see this in one of my future videos. It's part of the test equipment for the wearing test. And now the conclusions. Well, I will start with the positive things, and that's when it starts with the printing correctly. This means that the leveling checkbox is enabled. It prints great. The quality is fantastic and it prints fast. Actually, it is a little bit faster even from the Bambolet, for example. I really like that fast nozzle change method. And also I really like this sealing on these doors and the top cover. It is great because it not only gives better the heat inside, but also it is quieter. There is no resonance or vibrations or something like that. And actually, when it is closed, it is the quietest coreXY printer I tested so far. When it's open, then let's say it is equal with the others. Now a few things which I didn't like. Well, as I mentioned, from hardware side, this is great printer. The only thing which I didn't like is actually the position of the spool holder, which is on the back side, but it can be very easily mounted to the side because the entry, this Teflon tube, is actually in this corner. Now, biggest problem with this printer is from the software side in all three categories: the firmware, the slicer, and the website. Let's start with the firmware. Just few main things to mention, for example, that leveling. When we start with the printing, very important to check that leveling button, or otherwise we cannot get nice adhesion to the bed. This means it didn't record that data from the calibration process, you know, that 9 minutes calibration. I'm not sure why. Now, the other thing, for example, the changing the filament. This is very strange method. I was thinking about it a lot, and this is not good method. I saw that some colleagues, YouTubers, were amazed with this filament change method. With this method, the old filament will be just extruded and it will be pushed out by new filament. And with this method, we will always have some material in the nozzle and the heat break if we want to take it out or something like that. So we cannot completely remove the material from the nozzle. If you want to prevent that small bulb on the end of the filament, everybody is familiar with this who use manually their printer. We have to extrude a little bit and then pull out the material, and in this case we don't have that clog in the nozzle and removing is very smooth. I also noticed few bugs in the firmware. For example, for me, that auto power off doesn't work. Even if it was checked, it never powered off. But even that power off, I always can hear some fans inside, even in the standby position. From the slicer, well, if you check their website, you can see that first you will see instructions for the Orca slicer, and that's fine. But only in the second step you will find the flash print. But if you want to use the Wi-Fi connection, you have to use the flash print, which is a little bit limited compared to the Orca slicer. But even then, you don't have the full access control of the printer, like with the clipper. You cannot see, I don't know, the list of the files, or you cannot download the time-lapse video and similar. And even if you want to upload the G-code, you can just do it with the starting of the printing. And in that case, that leveling process will be skipped. My method actually for the Wi-Fi connection, if I don't want to use the USB drive, is to send the printing with this method. But immediately then when it is uploaded, stop the printing and then start the printing from the screen. So the very big question is actually why is that leveling not enabled by default, for example, or why don't I have the option in the Wi-Fi uploading? And why didn't record those settings from the calibration? Now, good news is actually that all these things can be fixed even on existing machines by the firmware update, new slicer download and similar. Now, the problem is that depend of the Flashforge approach, because I noticed that these problems appeared maybe 3 months ago, so they know about these problems, but here the problem still exists. And about their approach to the customers, I can always see from the website. For example, I was curious about the nozzle, because I don't have that information. What was the material of the nozzle? Actually, I get later the answer from the support. But on the website, we don't have the information, anything, just a title that it is 0.4 or 0.6 millimeter nozzle. Then I wanted to buy some build plates, because I always like to have at least 2. But again, on the website, we can see only the title, the price, and very long description about the warranty, but no information about the, I don't know, what temperature we have to use for what materials, do we have to use the glue stick and similar. So if I would be the head of the Flashforge, definitely I will keep the hardware group of engineers, but to those from the software side, I will give them 1 month to fix all these problems, otherwise they should be replaced. Maybe even better would be to place, I don't know, pure clipper on it. Maybe I was thinking BQ clipper screen to connect on it, but I have some other plans with it. So these software side things can be fixed very easily even on the existing machines, but the question is if the Flashforge and when will they do it. This was my experience, so this can be really, really great printer, but these things on the software side must be fixed. Thank you for watching and happy printing!